Alright guys, so this is 8-6, which is dealing with the perimeters and areas of similar figures. So basically what's going to happen is you're going to be given two similar figures, and you're going to have to use the similarity between those two to help you to find the perimeter and help you to find the area a lot quicker. So what I'm going to do is I'm going to break down real quick exactly what we mean by similar figures and how we can break down the perimeter and area. So here we go. So let's say I have two squares right here. And right now I have a square with the dimensions of 2 and 2. And so what I'm going to do is I'm going to analyze what happens whenever I raise each dimension by a scale factor of 2. Remember, scale factor means you're going to multiply by that number. So what I'm going to do is I'm going to take each leg and I'm going to multiply it by a scale factor of 2. So I'm going to multiply it times 2. So right now 2 times 2 is going to be 4. And on this dimension 2 times 2 is going to be 4. And so what I'm going to do is I'm going to analyze this and show you what's going to happen here. So first I'm going to look at what happens to the perimeter and area with the 2 by 2. So automatically we know to find perimeter I'm just going to add up all the sides, or since all of them are the same is I'm going to multiply 2 times how many sides there are. So 2 times 4 is obviously going to be 8. Okay? Now to find area of a square all I'm going to do is length times width. So 2 times 2 is going to be 4. So the area is going to be 4. So now what I really want to key in on is what happens with the similar figures whenever I move from this one to the scale factor of 2. So let's go and look at it. So to find perimeter, I'm going to do 4 times the number of sides, so 4 times 4, which is 16. And then for area, I'm going to do 4 times 4, which is also going to be 16 because length times width. So what I want you guys to really hone in on is I want you to remember that anytime we're doing anything with area, it's always going to be in squared units. So remember, squared. I want you to keep that in your head. So first I'm going to look and see what happened in between my two perimeters here. So going from the perimeter of 8 to the perimeter of 16, it looks like all I did was multiply by 2. Isn't that what my scale factor was? So to find perimeter, all you have to do is multiply by the scale factor. So I'm going to multiply, the scale factor is going to be 2 as well. But the main thing I want you to look at, remember I said area is always in squared units. So look from area to area here, we went from 4 to 16. So what did I multiply by this 4 to get to 16? Well, we know 4 times 4 is 16. So let's go ahead and look at that. So 4 times 4 is 16, correct? Well, I want you to look. My scale factor was 2, correct? Well, if I look at 4, I know 2 squared is going to be 4. So all I did was to go from area as I took the scale factor and I squared it. So we're going to take that piece of information and we're going to use it to help me with similar figures. So the area scale factor, all I have to do is take the perimeter scale factor, which was 2. So I went from scale factor of 2 and I squared it. So anytime you're working in between these, all you're going to do is square to get to the area, and then you can also square root it to get back to perimeter. And we're going to use that information to help us to solve this stuff. Okay, so on this first example, what I'm going to show you is whenever you're given two similar figures and you're given one dimension of these, you can use that, since you know that they're similar, to help you to find a perimeter ratio, to help you to find a perimeter in the future, or also to help you to find an area ratio. Because earlier I talked about there's something called a scale factor, and remember, the perimeter is just going to be the scale factor, and then the area is going to be that scale factor squared. So basically all I have to do in order to use these is I'm going to find something called a perimeter ratio and then an area ratio, and then I'm going to show you how to use those here in a second. So first, to find a perimeter ratio, all I have to do is take my two dimensions and put them over each other to create a ratio. So I'm going to do 6 over 9. So I'm going to do the smaller triangle to the larger triangle. And what you see here is 6 over 9 can be reduced. So 6 over 9 is also can be reduced by 3. So 6 divided by 3 is 2. 9 divided by 3 is 3. Can be reduced to 2 over 3. So my perimeter ratio is going to be 2 over 3. So what I can do later is I can take this ratio, and let's say I only know the perimeter of the smaller one, then I can use this ratio to find the perimeter of the big one. Okay? Just by using that ratio. Alright? So now earlier we learned that the ratio or the scale factor going from the perimeter to the area, remember, area is always represented as square units. That's how I always remember this. So all I literally have to do is take the perimeter ratio and square it. So I'm literally going to take the perimeter ratio of 2 over 3, and I'm going to square this. So all I have to do is 2 squared is going to be 4, and then 3 squared is going to be 9. So the area ratio is going to be 4 over 9. So then I could use this to help me define the area later. So let's say I knew the area of the smaller one, then I could use this ratio to help me to find the area of the bigger triangle. So it works back and forth, okay? Okay, so now what I'm going to do is I'm going to take the information I just showed you on how to take the perimeter ratio and turn it into the area ratio, and I'm going to use that area ratio to help me to find the area of this pentagon. So remember, these two figures are going to be similar. This only works when you have similar figures. So the first thing I need to do in order to find the area of this bigger pentagon here is I need to figure out first my perimeter ratio. So the first thing I'm going to do is find my perimeter ratio. So perimeter ratio. And so all I have to do is take two measurements that are basically corresponding on these shapes and write it as a ratio. So this bottom line and this bottom line are corresponding, so I'm going to do 4 over 10. So I'm going to take 4 over 10, and the first thing you need to do is reduce that ratio. So 4 and 10 can both be reduced by 2. So 4 divided by 2 is 2. 10 divided by 2 is 5. So my perimeter ratio is going to be 2 over 5. So let's say I wanted to find, if I knew the perimeter of this one and I wanted to find the perimeter of the bigger one, I could use this ratio. But I'm dealing with areas. So I need to find the area ratio. So remember, I told you guys earlier that area is always measured in squared units. So that means I'm going to take the perimeter ratio and I'm going to square it. So I'm going to do 2 squared, which is going to be 4. And I'm going to do 5 squared, which is going to be 25. So ladies and gentlemen, the area ratio is going to be 4 over 25. So now that I know these two pentagons are similar figures, I now can use the area ratio, which is the smaller one to the bigger one, and use it to find my bigger one. Because look, right now, I can see the area of the smaller one is 27.5 centimeters squared. So right now my area ratio is 4 over 25. Remember, smaller one to bigger one. So right now I know my smaller area, which is 27.5, and then I need to find the bigger one, which I'm going to represent as x. So now literally all I got to do, ladies and gentlemen, is cross multiply and solve for x. So right now, 4 times x is going to be 4x, and then let me snag a calculator real quick. Okay. So then right here, 25 times 27.5 is going to be 687.5. Then all I have to do is divide by 4 on both sides. So divide by 4, and this is going to give me, x is going to be approximately 171.9, and it's going to be in centimeters squared. So ladies and gentlemen, this is how you can find the perimeter ratio, turn it into the area ratio, and then you can use that to find the area of your bigger figure. Okay, the last example that I'm going to show you guys is how to basically take the areas and turn it back into the perimeter ratio. So earlier I told you guys about scale factor and perimeter ratio and area ratio and how to use them. So now I'm given 2 right triangles here and they're similar. Remember, this only works whenever you have similar figures. And I have the areas of both of those. So basically what I'm going to do is I'm going to create an area ratio first. So area ratio, all I'm going to do is take the bigger one and put it over the smaller one. So I'm going to do 50 over 98. And if you actually reduced this, this is then going to turn into 25 over 49. So this right here, ladies and gentlemen, is going to be your area ratio. So now we need to turn that into the perimeter ratio. So I told you guys earlier, if I go from perimeter ratio to the area ratio, remember, area is always in squared units. I would take the perimeter and I would square it to get the area, right? So now working backwards, remember, the squared, the opposite of that is taking the square root. So after I reduce this, you then would take the square root of your perimeter area, or your area. So I'm going to take 25 over 49. I'm going to take the square root of that whole thing. So the square root of 25 is going to be 5. The square root of 49 is going to be 7. So then your perimeter ratio would be 5 over 7. So going to area, you would square it. Going back to perimeter, you would take the square root. And what this is going to do now, if I knew, let's say I knew the perimeter of the big guy, then I could take the perimeter of the big guy, set it equal to this ratio, and then find the perimeter of the smaller one. So there's a lot you can do whenever you're dealing with similar figures. So this is what I want to show you on 8-6. Good luck on the practice.